Hi everyone, welcome to this session and welcome to J4K. I'm truly happy to be with you guys here today, right now, and I'm truly happy also for this opportunity to share some content, some knowledge with you. So let's talk about chaos engineering and how it can help you to assure that your service will be available or to increase the availability of your service. And in the end of the day, of course, how it can help you to make your customers, your clients' lives better, all right? Because that's why we develop software, right? We develop software to help someone to increase productivity, to make life of someone better and not miserable. And that's one of the applications that we can use chaos engineering. And I will let you know some concepts before we go in more deep diving on chaos engineering. And the first one is this: chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in productions. All right, so this whole definition you can find on this website, principlesofchaos.org. And one of the first interesting things about this website is that is a website where you can contribute. It's a collaborative website, and it was created by the team of chaos engineering that were working on Netflix, right? So, and I made a highlight here on some of the words that will be very important for us today. Of course, chaos engineering, the discipline that we are studying, experimenting, right? Because chaos engineering involves a lot of experimentation. Build confidence, that is the end target of the whole work on chaos engineering is building confidence on your system. And turbulent conditions, right? Because it's usual that the unusual happens, right? So the unpredictable, it's almost certain to happen on your system. That's why we create some experiments. And the final word is the scariest word of this whole discipline, that is production. Because, and I would like to make it very clear since the beginning, is that the chaos engineering only will help you if you make it happen as close as possible to production, and it's preferably that is happens on production. Don't say words to me, okay? Don't be afraid. I will let you know how you can do it in a most safe way as possible, right? Well, resilience. It's common today to hear about resilience, and resilience is not something that your system will not fail, will not have problems, but the resilience is the adaptability of your system, not the capability of not fail, but the adaptability of a system when facing changes, failures, and anomalies, right? So I like to use the example, for example, of a Gmail. I'm sure that many of you guys here today use Gmail, has a Gmail account. And if you use the web site of Gmail, maybe you already saw it switching to the classical mode when you are with a bad internet connection, for example, and you are using a web portal for Gmail. Sometimes it switches to classical mode. In the classical mode, it doesn't have a lot of the user experience where you're having the regular portal of Gmail. This is a kind of resilience, okay, because the system is adapting to a anomaly that is a bad interconnection collection. And we also call it graceful degradation. So the system is degrading, and it has a feature to do it in a graceful way. Okay, that's a kind of resilience. So it's not enough your system just don't fail, just don't stop running, but it's also important to be able to adapt in case of some unpredictable stuff happens. Another, it's create failure on purpose before they happen unexpectedly, right? That's the whole point of chaos engineering. You create failure on purpose, on a controlled way, on a managed way, before it can happen unexpectedly. And the last assumption that I'm going to do right now is find weaknesses and fix them, all right? If you are not willing to fix the weaknesses that you find, please don't even stop doing this, because it's a waste of time, right? So unless you are really committed to improve your system, the features, the capability, the adaptability of your system, don't even start doing this, because you will just waste your time, all right? But in the opposite, if you are willing to really improve, yes, do it, all right? So before go forward, let me just introduce myself really quickly. My name is Elder Moraes, and I'm sharing with you here the URL and the QR code of my YouTube channel, where on a weekly basis, I share content about Java, microservice, containers, cloud native, and I share content both in Portuguese and English. So I'm Brazilian, and I'm trying to share the content in both languages to help more people. I'm a developer advocate here at Red Hat, and my mission here as a developer advocate is to help you, developer, to build and to deliver applications that are available, that are with high performance, in order that you have great success on your project. I have just released the second edition of my book, the Jakarta EE Cookbook. So if you like Jakarta EE, if you like to work on enterprise applications using Java, maybe my book can help you. And I'm also a board member at So Java, one of the biggest Java user groups of the world. All right. So that's it. I'm introducing right now. All right. So some examples of where to inject chaos, right? So those are examples, all right? It's not a final list, not even close, all right? But one example where you can inject some chaos, it's your application itself. Your application has some data flow, some business politics, some business policies, right? Some rules, some whatever configurations. So it's a huge field to test the way that your application works is by starting to inject chaos on your application itself. The second one is cache, because today we are increasing a lot the use of cache, especially on cloud native applications, on environments where you need really fast access to some data that doesn't change a lot. So caching is very important. So you can, for example, if your application depends on some cache, what happens if that caching is not available, or if that cache is being built? I'm working on a company where this one of cache that they use it took like 20 minutes to build the whole cache. So what if I'm trying to access that cache and it's being built? All right, so that's some kind of chaos injection that you could plan for your application. The third one is database. So if my application uses some database, what if the database is not available? What if the database is too slow? What if I drop some index? Okay, so this kind of test on database is also incredible for trying chaos injection. And the last one is your cloud or your infrastructure. So what if a server is down? What if a container is down? What if I try to access some port is not available? What if I use some service of my cloud vendor and that service is down? So this kind of unpredictable stuff you can use to inject chaos on your application. And chaos engineering, we can split it on 5 phases that I'm gonna just show you, and I will explain each one of them in a second. The first one is the steady state, is the way that your application, that your system works, where when everything is fine, is okay, it's doing great. The second phase is hypothesis, where you start asking questions about your system. What if this happened? What if that happened? What if those happen? The third phase is the design and execution. So based on the questions that you asked on the hypothesis, so you design your experiment and you execute your experiments in this phase. The fourth phase is the lessons learned phase. So you get all the results that you gather from the execution, and then what you learned. Okay, so what happened in that experiment. And the phase number 5 is the fix. Okay, the fix where you got all those lessons learned and you got the weaknesses of your system, and then you fix it. So the first one is the steady state phase. Okay, the first phase of your whole chaos work, and it is the most important one. And the steady state is the usual behavior of a service based on the business metric. All right. So this is a graphic that I took from this article from the Netflix tech blog. You can check it out. It's a graphic of the business metric for Netflix, and it's called SPS, that is strings per second. What is strings per second for them? It's the ability, the capability of Netflix to start new streams on each second. All right. So if you realize, it's not a metric related to I/O, to requests, to some kind of speed of response time, not like that. It's a business metric. It's a metric that's explains, showing up how my client, how my customer is, what's the experience of my customer with my system in that moment. And this graphic, it's a week graphic. All right, so here we have Sunday to Saturday, and we have 2 weeks, overlapping of 2 weeks here. You can see there are 2 lines on the graphic, because it's important to say that, and we would tend to say, oh, it's awesome if I could, for Netflix, for example, if I could open as much streams per second as possible. But my customer doesn't behave like that, right? So probably here we are on a time where people are sleeping or are working, or here they are at home, or here they are on another time. So it's usual that my customer have some variations on the behavior. So that's why we need to monitor this business metric on a period of time that makes sense for my business. For them, it's on a weekly basis. All right. And speaking about metrics, and metrics are a key stuff for chaos engineering. That's why I will make a kind of stop here to think about it, to talk about a little more about metrics. Oops. Yeah. All right, so what is a metric? A metric is a measure used to evaluate, to control, and or to select quantitatively a person, an event, or an institution. All right, so keep on your mind this word quantitatively. And why I'm saying that? For example, imagine then that you work on a company and you have some index, some key result, for example, where your manager will evaluate you. So, for example, imagine that your manager demands you to work well with your teammates. Okay, so team collaboration is one of your key results. And in the end of the period, a year, for example, your manager comes to you and say, well, you did great, you work well with your team, so your team collaboration is good. Okay, you thank your manager and go home. But another manager in the same period of time could work to the same work that you did and say to you, well, I don't think you did great, I think you should improve, because this kind of metric, it's abstract, okay, it's not something concrete. That's why we are saying here that we need to have something quantitatively, to measure something quantitatively when we are thinking about metrics for service. Well, another example in the same case is if your key result would be to bring $1 million of revenue to your company, and then you brought 1.5 million. Awesome, okay, because no one would question, no matter who manager would evaluate you, if you had a target of 1 million and you brought 1.5 million, great, all right, because it's concrete, no one would question. All right, and as we are saying here about metric and service, metric has a deep relationship with health check, because and today when we are thinking about availability of service, it's usual to people look at health check. Well, my service is up or is down. My service is up and is ready, and is up but is not ready. So this kind of verification on health check are very common. But it's not enough, because saying that my service is just up and it's ready doesn't tell me how it's the experience of my user. Okay, but if my service is just up and working, it's up and ready, doesn't mean that my user is having a good experience if the requests are responding in the time that my user needs. So we need to make a relationship between the metrics and the health check, because the metrics will give you the quality of the health check, the quality of the availability of your system. And for show you an example of this, I prepared a service, the Rock Balboa service, all right? And for Rock Balboa service, I will show you how the metrics relates to health check, all right? So here we have the Rock Balboa service on two conditions. First condition, before the fight against Ivan Drago. Do you remember Rock Balboa, Ivan Drago? Okay. And the second, after the fight against Ivan Drago. Okay, so first before the fight, and second after the fight. Before the fight, I took I got all the metrics from the service, Rock Balboa service. So the punch power was 100%, the bleeding was 0 millimeters per second, eyesight was 100%, sweating was just 1 millimeters per second, so just to take the picture and look great on the picture, milliliters, not millimeters, milliliters per second. The confidence is 10, and pronunciation, if you ask him what's the name of your wife, he would answer Adrian. Okay, all perfect. So 15 rounds against Ivan Drago, and then this condition of our service, and then we got the metrics again, and now the punch power is 0.5%. The bleeding is 100 milliliters per second. So in 10 seconds, he will have some problem. Eyesight is negative 10%. So instead of blind, he's also disoriented. The sweating is 100 milliliters per second. His confidence is 0. And the pronunciation, if you ask him the name of his wife, he will answer something that I just can't say. Okay, I'm not able to say that. So in both cases, my service is live, but in the second case, you don't know for how much time. All right, that's why metrics are really important to combine with health check and to say to you how is the experience of your user on your system. All right, back to chaos. And then we come to the second phase, hypothesis. This is the phase where you start asking questions about your system. So, for example, we will show you some examples of questions. What if a service returns a 404? What if a database stops working? What if the amount of requests spikes up? What if the latency grows 100%? What if a container is killed? What if a port becomes inaccessible? And etc, etc. And of course, you will ask questions about your system. And the important part of these questions is that you need to be very open, okay? So you need to ask questions in a variable way. And don't be afraid to ask questions that you really don't know the answer, and even questions that you think that you know the answer. For example, oh, if my database stopped working, don't worry, my application handles that. Well, you really tried to stop a database and let your application work to see how it's handled this condition. So it's important to test everything. And then the next phase, design and execution. So here we have some best practice. So you have a lot of questions that you asked about your system. Then you will start designing and execute the experiments. So some best practice. First, start small with baby steps, all right? Don't start stopping all the servers, all the nodes of your application, no, because it will not work at all. So if you have, for example, 3 nodes, 2 nodes, stop one, or stop some parts of the service, or stop the service for a small amount of users, for example. I will show you some strategy to do that. But start small, even for negotiating with your managers, with the users, because I once heard about a big company where they negotiated for 2 years in order to have the first chaos experiment, because all the involved people, all the stakeholders on the company didn't agree to have someone stopping some service on production. So they really needed to negotiate, to show, to prove, and of course start small, right? As close as possible of the production environment. And here there are very simple concepts to determine it. Because if you run chaos engineering on a text environment, you will improve the text environment, right? If you run chaos engineering on a quality assurance environment, you will improve the quality assurance environment, all right? So if you run on a production environment, you will, of course, improve the production environment. Oh, but my test environment is very equal, it's exactly the same. It can be exactly the same, but it's not the same. It will never be the same, right? Because your users on production behave on a way that you will not behave on your environment inside the company, right? So that's why it's very important to really run in production, to make the work as hard as possible to run the experiments on production. Minimize the impact as much as possible, because of course, as I said, you don't want to stop your whole environment. You don't want to make the life of your users miserable. You don't want to get all users of your database and stop them and the application is not available for everyone. No, no, no. You will take the baby steps approach even when choosing the amount of impact that this experiment will have on your application, right? So minimize as much as possible. Have an emergency button, right? Because sometimes things goes wrong. That's why we are running chaos engineering. So have some way to stop really an emergency way if something didn't work as expected. And the last step here is to automate, right? So because it's the same case when you are running tests. If you don't automate a test, you probably will not run it again, or it will just run it when you remember and you will not remember so often. So it's really important to automate, because this kind of test will take a lot of hard work to build, and it will make your life much more easier if you just automate it. And one kind of approach that you can use in order to have to reduce the impact, in order to have an emergency button, in order to don't make the life of your users miserable, is to use a kind of canary deployment way to build to design and to execute these experiments. So for example, you have your users, and let's suppose that your users access your application through a load balancer. So you can use your load balancer to tag some users, to separate your users in 3 groups, for example, that will help you to make this experiment as safer and with a minimum impact as possible. So for example, you created 3 tags here. One tag will be the steady state. It will be the users that will just follow the normal life, the regular life. They will not be affected by the experiment. The second group, it will be just 1% of your whole users base, and it will be a control group. The control group will have exactly the same behavior as the steady state, okay? But it is very important, and I will tell you why. And the third group is the chaos group, another 1% where you will inject the chaos. Why it's important to have the control group and the chaos group in the same size? Because then you have some comparisons, so comparative related to the metrics, for example. Because if you compare 1% of your base with 90-80%, it's not fair, all right? It will not show you really the impact of this experiment. But if you have, for example, 1,000 users not being affected and 1,000 users being affected, you can plot a graph, you can see the metrics, you can see the behavior, and really have a better idea of what is happening. All right, so you just run it, the whole experiment, and then you design it, you run it, execute it, and now we have the lessons learned phase. All right, and here I will bring you some ideas for discussion that you can use for this. It should be a meeting. Some call this a post-mortem meeting. It should be a friendly meeting in the end of execution, where people will sit down, will get together and really share the lessons learned. It's not an opportunity to blame each other. It's not an opportunity to say you did this, you did that, you didn't do this, you didn't do that. But it's an opportunity to share lessons learned. Okay, so for example, how much time for the failure being detected? Did someone get a notification? How long it took to get a notification? There was a graceful degradation. How long until it starts? Our application has had the graceful degradation. How long it starts to start? How long until auto recovery? partial and full. Okay, if your application has an auto recovery feature, how long it took to happen. There was a need for manual intervention, so someone needed to open a terminal and start doing stuff in order to application got back. How long until to be back to steady state? So you have a steady state mapped. How long after the chaos for application be back to that state? And then we got to the last phase, okay, the fix phase. And this phase is very clear, all right? Okay, or you fix or you don't fix, all right? So there is no discussion here. And as I said in the beginning, if you are willing to spend this whole amount of time, it's not easy, all right? If you spend this whole amount of time to find the weaknesses and you are not willing to fix them, I think that you should not even try it, right? That's my point here. All right, and here I'll finish this first part of the presentation with our friend Dracula from Bram Stoker, where he said, we learn from failure, not from success. All right. And right now I will pass through the second part of this presentation where I will show you how we can manage to do chaos engineering with Kubernetes. All right, and for that I will just start I have an application that I will show you in a bit. This application here, it's deployed on a Kubernetes cluster. This is the book info sample from Istio. If you download the Istio service mesh, it comes with a lot of example applications. This is one of them. And I will here, using BlazeMeter, I will have a load test, a stress test here, where I will simulate 50 users during 20 minutes and sending requests to this application. All right, we'll be back in a second. Right now I will just keep with our slides here. All right, so Kubernetes is perfect for chaos engineering. Why? First, because it has native features for resilience. Okay, so on the core of Kubernetes, there are a lot of native features that I made to provide resilience to your application. So we can, it's perfect for trying, it's perfect for injecting chaos. The pods on Kubernetes are restarted and recreated based on health check and status. So if you have some metric that you are trying to prove, to test, Kubernetes will be much more easier to do that because it's made for that. And 3, pods can be distributed on different regions. So for example, if you have an application that you have clusters distributed in your country or even on different countries, you can try, for example, to shut down some region, to shut down some cluster, and test how your application manages that anomaly. All right, so there are some tools that you can use for chaos with Kubernetes. So for example, the first one is Istio. Some part of my demo today will be based on Istio. Another one very well known is the Chaos Monkey. Another one also well known for people who love to study about chaos is Chaos Kong. And the fourth is KubeMonkey, is what I will use today to show my experience to you. So some examples here using Istio. Istio is a service mesh that works on Kubernetes that will handle all the communication between your applications. So here we have 2 examples of failure injection using Istio. So you will just got the deployment YAML file of your application and put this section here. So it will create a fault, it will be a delay fixed for 7 seconds for 100% of the users that match this condition. the end user is JSON. See, here we are probably on the load balancer putting some tag on some amount of users, and here we are injecting this failure on these users. That's what I just showed you on my slide. The second here is kind of the same case, but we are putting some HTTP status 500 to the JSON. So JSON will got a delay in some 500 as well. So that's how one of the ways that we inject failures using Istio. And here you have let me here, yes, a whole article about it on the Istio website. Another tool is very well known, Chaos Monkey, was created by Netflix, but it's also open source. So here it works on the environment side of the application, so it will randomly kill virtual machines and containers. It's natively integrated with Spinnaker. It's an automation tool, so if you use Spinnaker, Chaos Monkey is integrated since the beginning. It has support to AWS, GCP, Azure, Cloud Foundry, and of course Kubernetes. And here we have the GitHub, where you can go there and check more information, contribution, and so on. Chaos Kong, for me, is the funniest one. Okay, it's a tool also created by Netflix. It's not open source. You can't find the code public access, but it kills an entire cloud region through simulation, of course. I saw a talk from one of the Chaos engineers from Netflix, and he said, well, we tried, but the cloud vendor didn't give us an API to kill the region. And this kind of incident, this kind of things, it's rare, but they happen. And if you search on Google, you will see that once, I believe that once or twice, that one of the regions that Netflix works went down, right? And the service kept running, right? Because they were running chaos testing, simulating this kind of incident, this kind of anomaly, as the entire region going down. They were testing it for a long time, right? So once it really happened on a true life, they were well prepared and didn't suffer with especially the users didn't suffer, right? So that's why for them it were very, very important. And I heard that even still today they run this kind of simulation on each 15 days, I believe. So once or twice a month they run this kind of simulation, dropping an entire region on their service, and it's part of their lives. Okay, so everything that is built inside Netflix is built to support this kind of incident. So here we have some other articles where you can read more about it. All right, and finally the Cube Monkey, that will be what I'm gonna show you in a couple of seconds. It's an open source project, also on GitHub. Here you can find the address. It's based on the Chaos Monkey, but it's made specifically for Kubernetes. That's why it's called Cube Monkey. And it's built on an opt-in approach, so you really need to go on your application and inform that your application allows KubeMonkey to kill its pods. So that's how it works. Okay, so there are a lot of configuration. I won't explore too much, and let's pray to the demo gods so our demo really works today. All right, let me jump here. So our test is running here. and here is the application, and here is the KubeMonkey. I won't show you right now. Let me switch to my terminal here. What do I have here? So here I have the pods of my application, this application here. Okay, so there are some microservices there, and one of those microservices I have 10 instances, 10 pods for the. You look that we just have some pods killed here, right? So here in this terminal I have the KubeMonkey. It's an application inside the Kubernetes. It has a pod, and it's just a plain, regular application. And on each 30 seconds, I configure it as a debug. So I'm running on each 30 seconds. He's coming here and dropping the 70% of my pods, all right? So my whole configuration here is just like that. So here is just have an execution, and in the next one it will try to drop again. And as you said here, 40 seconds, fine. So it's really killing my application. What I'm gonna just open here is a Grafana. CTL dashboard Grafana. So we can see how our application is managing this chaos, this stress that it's living right now. So let's just wait for our Istio. And mesh. If we take here from the last 15 minutes on each file, all right. So our test is running, all right. And right now we have here something like 80 to 9 operations per second. And here is a way where we can monitor our test, our try here. Let me just see here the execution. All right, it's still running. Okay. So that's it. So we are really live here. Here you can see that we got a really big spike, and right now we are kind of decreasing. It's important. The whole point here is to see how your application it's behaving. So for example, you can see that we didn't have any 400 errors, any 500 errors here. So even killing 70% of our pods here, so we have 10 pods, even killing 7 pods per time is not making our users to not having access to application. So application is still running. If we go here and have try something here, application is there. All right, we could make stuff really something more interesting here. We could, for example, go here, we'll create another terminal, and I will cube. Let me switch this. Oops. What? kubectl get deploy. Oops, deploy. Oops, kubectl. All right, so I will edit this deploy here. It's good that you also see how it works. So kubectl edit deploy product page. It will open the deployment of this application. Let me bring it here. No. All right, so if you look here, we are on a fixed percent of 70%, right? So I can change it to kill all. So every time that it runs, it will kill all my pods of this application, right? Let me here. So here Kubernetes is changing the application, so it's recreating the pods. All right, so container creating. And the next time where here, oh, look that QBMonkey here is scheduling the next execution. It will be on 30 seconds, I believe. Right now we have all our new pods working. So 25 seconds, and in a few seconds it will kill again, or at least send. Looks so it sends, yes, so it sends the request to kill the pods. Now some of them were killed. Actually all of them were killed, just yes. So that's how it happens when you works with QBMonkey. So here we have some examples of just show you. First, it's automated, so it's working, it's running here, so I keep this test running over and over again. I can have I can control my impact of this test. So I started with 70%, then I increased it to 100%, but I could use 10%, for example. So you can see it's killing again. So I have this kind of control over my tests if I use the QBMonkey in the way that I'm using right here. All right, so that's what I would like to show you. I see that it just worked. Thank you, Demogods. And I would like to finish with a statement made by a next senior engineer from Netflix. Nora Jones is not the singer, all right? So it's a senior chaos engineer, where she said chaos doesn't cause problems, it reveals them, right? So don't think that by using chaos engineering you will cause problems on your application. No. You will find the problems, all right? You will find the weaknesses, and I hope that you are willing to fix them. All right, so that's it. I would like to let you with this URL from Red Hat developers, where you can find a lot of resources about Java, containers, microservice, Kubernetes, Istio, Tecton, RHEL, Red Hat Enterprise Linux, and a lot of cool stuff for developers. So you can scan this QR code or visit developer.redhat.com. And I would like to end by thank you very much for being here. Thank you for your time. And if you have any question, doesn't hesitate to drop a message on my Twitter. My DMs are open. And I hope to see you next time. Bye-bye.